Physics students, good afternoon. Mr. Fugit here. Today in this video we're going to be looking at a pretty straightforward basic problem involving circular motion, an object moving in a circle. We're going to do some calculation with finding the centripetal force for an object that's moving in a circle. Specifically, this problem is geared towards number 1 on your homework assignment 7, which covers over circular motion and universal gravitation. So I'll read our problem statement for us and we'll get started. It says this: a 48.6 kilogram ice skater is moving at 2.61 meters per second when she grabs the loose end of a rope, the opposite end of which is tied to a pole. She then moves in a circle of radius 0.718 meters around the pole. Find the force exerted by the rope on her arms. Acceleration of gravity is 9.8 meters per second squared. So to get kind of a visual of what's going on here, let's kind of take a bird's eye view of what's happening. So if we were to kind of look down on what's going on. In the center, we have our pole. Our ice skater is coming in. She's going to grab a hold of the pole, or excuse me, grab a hold of a rope that will swing her around the pole in a circle like so. Okay? So we're dealing with, as we have really a lot the last month or so, an object moving in a circle. Now, as we've talked about, objects moving in a circle must have a centripetal force, something directed toward the center of that would-be circle. Now in this scenario, that force is what we would call a force of tension, okay? A force coming from a string or a rope. Okay? And so what we need to do here is make the connection that our tension force is in fact a centripetal force. It's a force directed toward the center. And fortunately for us, we have a way of calculating a centripetal force. Centripetal force, as we have found, is equal to the mass of our object times its velocity squared divided by the radius of the circle it moves in. So if we look at our problem statement, we're going to find we're given a lot of important information here. One, our mass is 48.6 kilograms. We're also told our velocity, okay, kind of our speed around the circle, is 2.61 meters per second. And lastly, we're also told the radius of the circle that she's moving in is 0.718 meters. That's this distance from center to the outside, 0.718 meters. So to find our centripetal force, we need mass, velocity, and radius, and the problem statement gives that to us directly. So here, all I'm going to do is plug those variables in. Centripetal force is mass, 48.6 kilograms, times our velocity, which is 2.61 meters per second squared, divided by the radius of our circle, 0.718 meters. So now it's just a matter of plugging those values in. Let's see what we come up with. 48.6 kilograms times 2.61 meters per second squared divided by 0.718 meters. That's going to give us a value for our centripetal force, Fc. We did plug in kilograms and meters in seconds, so that should give us a value for force in newtons, which is 461. Let's go with 0.09 newtons. That would be my value. Now, one thing we have to be a little bit careful of for this specific problem is that it is asking us to find that force in kilonewtons, to present our answer in kilonewtons. Okay? So if you remember, 1 kilo is 1,000. Okay? So, or 1,000, right? So if I want to convert from newtons to kilonewtons, I can divide this value by 1,000. Okay? Yeah, which is going to leave us with a centripetal force of 0.461, kilonewtons. Okay? Just another way of expressing force. Okay? So really this problem is asking us to solve just for a straightforward centripetal force, but to present that in a specific unit, kilonewtons. Okay? So here we're just going to solve that appropriately like we have for any centripetal force, mass times velocity squared divided by the radius. Now to tackle on, there's a second part to this question that we're going to tackle as well, but this should get us going on part number 1. Now the second part of our question says this: find the ratio of this tension to her weight. Okay? So this force right here, remember, our centripetal force is our tension force. And it's asking us for the ratio of tension to the weight. So in problem number 2, we want to find our ratio of our tension force, which is our centripetal force, to our weight. Now remember, weight is just another specific way of describing the gravitational force on your body. So that weight is really the same as Fg, our force of gravity. So we know that our force of gravity, let's solve for that first because we already have our tension force. Force of gravity, if we are on or near the surface of the Earth, which we're told we are here, mass times gravity. So I'll take a moment, plug in what I know. The mass we were given, I believe, was 48.6 kilograms times acceleration due to gravity for here on the Earth, which we're given in the problem is 9.8 meters per second squared. So I'll take a moment, plug these values in to my calculator. 48.6 times 9.8. That's going to give me a force of gravity of about 476.28 newtons. Okay, so now we have the other part of what we need to find our ratio. The tension force and our weight are the force of gravity. The only thing we have to be kind of specifically careful about here is that we make sure that the units on the top of our equation are the same as the units on the bottom. So don't let part 1 trip you up. Part 1, we presented that answer in kilonewtons. And it's fine if we want to stay in kilonewtons here, but what that would mean is that we would have to convert this value down here to kilonewtons as well. So I'm going to leave those values in newtons, because as long as our values are in the same units, it really doesn't matter what units we will use. So I'll take our centripetal force, or our force of tension, if you will, 461.09 newtons, and divide by the weight, the force of gravity that we just found, 476.28 newtons. Again, doesn't matter what unit we choose to use as long as they're consistent top to bottom. So I'll plug these values in, 461.09 divided by 476.28, and that should give us a ratio of about 0.968. So our ratio here, 0.968. Since we had units of newtons on top and bottom, this value is actually going to be unitless. It's just a ratio, a way of expressing kind of those values in comparison to one another. So if I check our answer key, 0.968, that's what we found, 0.968, we're good to go. So hopefully this will get you going better on problems 1 and 2. Just make sure you read the question carefully and think about how what we've covered in class specifically applies to this scenario. Okay? Best of luck. Remember, your numbers are going to be a little bit different than mine, but the process will remain the same. Okay? Best of luck.